This is a continuation of the Chapter 12 review, starting with problem 18. In problem 18, it's a basic volume of a composite solid problem, and I say basic because that's all it is two stacked cylinders. So that's all we have to do is find the volume of the base and the volume of the top. That should be fairly straightforward. Let's begin. We have volume equals area of the base, we'll call this area of the base 1 times height 1 plus area of the base 2 times height 2. So this will be base 1, this will be base 2. Let's go ahead and calculate that out. This is going to be pi, and r is 10 for the first base. So this is 10 squared, that's a 10, times the height is 6, plus area of the base 2, which is going to be pi, and this radius is 6, so it's pi 6 squared times this value, which is 6 again. So this is going to give us 600 pi plus 216 pi, which is 816 pi, which is going to give us approximately 2563.5 cubic inches. So altogether not too bad of a problem. Let's see if we can get a little bit more challenging one here in problem 19. In problem 19, we're looking for the volume of a cone. So let's begin. The volume of a cone is 1/3 area of the base times the height. This is 1/3, and it's going to be pi r squared times the height, which is pi 16 squared times 30. That gives us 2560 pi, which is approximately equal to 8042.5, and that is cubic centimeters. Alrighty. Not so challenging after all, but let's move on to problem 20, see what we can come up with. Problem 20 gives us an oblique pyramid, because you can see that the height is offset, it's not coming down to the center. So in this oblique pyramid, then we have an area of the base that's easily calculated and the height of the pyramid. Let's go ahead, write down our equation and solve it. For 20, volume equals 1/3 area of the base times the height, just like in the cone. This is 1/3. Area of the base is 10 times 18 times the height. Well, the height is just 5. And that gives us a volume of 300 cubic meters. Alrighty, let's move on to problem 21. For problem 21, we have an inverted cone. We're given the slant height and the radius. Now that slant height is going to help us in finding the height of the cone, which is what we're going to need to do volume. So let's get started here. For 21, volume is 1/3 area of the base times the height. And it's that height that we're going to have to calculate. So we know that this is 1/3 pi r, which is 7 squared, times the height. So for height, we know that h squared plus 7 squared equals 13 squared. We're going to subtract 7 squared, so h squared equals 13 squared, that's a squared, minus 7 squared. H equals the square root of 13 squared minus 7 squared. That's going to give us approximately 10.95. Again, we're not going to use this value. We're going to store this full decimal equivalent in the calculator, and we're going to use that value in this calculation. So this stored value is going to go over here, and that's what we're going to plug in to get our value. This is going to give us approximately 562.1 cubic meters. So other than just a quick Pythagorean sideline, we've got our actual value. No big deal here. Let's move on to problem 22. Problem 22 says the volume of a square pyramid is 1024 cubic inches. The base has a side length of 16 inches, and we need to find the height of the pyramid. So I think the important thing at this point is to go ahead and see if we can draw this thing. We have a square pyramid, so let's try and give that a shot here. Again, these don't have to be perfect. We're looking for the height of this pyramid. This is h. And we are given the volume equals 1024, and the side length is 16. So this is 16, 16, and since this is square, all these are congruent. So 16, 16, 16, 16. Well, the best thing to do to solve this is to write down the formula and see where we are. We know that volume equals 1/3 area of the base times the height. The volume is given to us as 1024, and that equals 1/3. Area of the base is 16 squared times the height. Well, this is a fairly easy problem. It's just a basic problem in algebra. Let's multiply both sides by 3 because this is the equivalent of 16 squared h over 3. So we multiply by 3. 3 times 1024 equals 16 squared h. Divide by 16 squared. 3 times 1024 over 16 squared equals h. We put that into our calculator and we should have the value for h. And h is 12. And since these dimensions are in inches, then we know that this is in inches. Okay, started out looking like a little more difficult problem, but turned out to be fairly straightforward. Let's go ahead and move on to problem 23. In problem 23, we have a cone with a diameter of 16 centimeters, has a volume of 320 pi cubic centimeters. We're looking again for the height at this point. So just like we did before with the last pyramid, let's go ahead and draw this cone and see what it tells us. So let's draw a cone here. And it has a diameter of 16. So this is a diameter, bad diameter. we're looking for the height. This will be h, and this value was 16. Well, that tells us that this is 8. Don't know if that's going to be important, but it should be, because we're going to look for the area of the base times height. So let's write down our formula. Volume equals 1/3 area of the base times height. They gave us the volume as 320 pi. 320 pi equals 1/3 area of the base. Area of the base is a circle, so it's going to be pi 8 squared times the height. So again, it looks like this is a basic algebra problem again. So we're just going to work through and get rid of all these values. This is 320 pi equals pi 8 squared h over 3. These are just equivalent statements, in case you're uncomfortable with this format. So now we are going to multiply by 3. So 3 times 320 pi equals pi 8 squared h. Now, to get rid of all this stuff, to solve for h, we're going to divide both sides by pi 8 squared. So 3 times 320 pi over pi 8 squared equals h. And here we can see that the pi's are going to cancel out. And let's just rewrite here. We have, that's a 320 by the way. We have 3 times 320 over 8 squared equals h. And that should give us our height. And that gives us a height of 15 centimeters. All right. Let's go ahead and move on to problem 24. In problem 24, we've moved into the world of spheres. So let's go ahead and find the surface area and volume of the sphere. To start off, let's put the formula. Surface area is 4 pi r squared. And the reason for that, as you remember in our lessons, that a circle with the same radius as the sphere would cover exactly 1/4 of the sphere. So 4 of those circles equals the surface area. This gives us 4 pi 7 squared, which is 196 pi, which is approximately 615.7, and that's going to be square inches. All right, volume is 4/3 pi r cubed, and that gives us 4/3 pi 7 cubed, which is approximately 1436.8. And the units is going to be cubic inches. All right. There's problem 24, and we will do problem 25 in our next video. So I will talk to you in the next video.